All right. Happy Monday. Just a quick question for you. You're not all going to take the next class. That's okay. But for some of you who are going to continue on and take 2001, I used to use a physical book, but that's a little bit expensive. They also had an ebook option. So Zybooks actually got it somehow. I don't know how that all works here. No, what is it here? So it's $64 to subscribe to the Zybook version of that book. What's the name of it here? But on Amazon, how much was it here? Structures and algorithms in Python. I think it was, which one was it here? Goodrich? Shoot. I should remember this guy's name here. There we go, Goodrich. By Goodrich. Goodrich. Let's develop, that's not it. This one here. So this one's a lot more, right, for the hardcover version. You can get other versions cheaper here. But cheaper is usually better, right? Even if it's a website. I know some people really like real books at some point to study out of. But I sort of like that you can go through and see these things, and like they've got stuff you can click on and like the built-in quizzes. I think this is worth it, right? Now, the other downside is, I guess it's not a downside, but it'll take a little bit of work. This same book is I should double check, I guess, I don't teach the course, in 350, Data Structures and Algorithm Analysis. We go through the first half or so, and then the second half is what you start with in that course, and then the prof gives you more above and beyond that. So like, you get a double dip with that one. To save your Zybook, you have to go in and like print one chapter at a time. So that's a little bit obnoxious, but doable, right? Versus if you bought the book once, you just hold on to it twice, right? So the plan was to tell the bookstore I want this one. You can still get the other ones if you want them here. I'm not going to give points for Zybooks in this next one because there's no labs for this one. But that's been the plan I had in mind here because I feel like that's a slightly better deal. And then like the little self-check stuff I think is actually pretty useful. Whether or not you think it's useful or not, up to you. But thoughts make sense? Okay, and 65 is not outrageous when it comes to a college text, which I feel bad saying that's not crazy to have to pay, but it's no $200 math book, which is crazy because math has not changed. Like calculus has been calculus for how long now?
I think you need a book. I don't feel like you should use a book for math, to be honest. It's all formulas and just implementing it.
Yeah, so a lot of what you get out of the math book is like the practice problems and then the answers, because sometimes practice problems are a little bit tough here. Okay, well that's my plan for next semester, so you don't have to buy a $150 book, physical book. There's also PDFs you can find online, but I do discourage those just because authors did go through some time, energy, and effort to put these things together. Not that it's worth $150 necessarily, but by the time they get their cut, that sort of thing. All right, got a little off track, sorry. But that was the plan. Ooh, that's a fun little pointer clicker. Someone must use one of those. All right, so we're moving on to new stuff, right? Every week we get new stuff. Super exciting. Functions is one of my favorite topics here. I love functions. They're super helpful. Now, when we get to functions, we're not actually going to be able to do anything more with code that we can't do today. But what functions let us do is put a name to a block of code. They let us have less repeated code, right? And it does give you lots of shortcuts for things. You can do things faster with functions. Now, I don't remember if I've said it often enough here, but pretty much anytime you have the same code in your program twice, you should feel bad about yourself. It's a pretty good rule of thumb. So functions are one of the key ways that we can not have duplicate code, not have the same code twice and feel bad about ourselves. So functions are going to help us with that. So let me fire up Zybooks here. Nope. PyCharm. Fire up PyCharm. Goodness, I got Zybooks on the brain now. All right. Here we go. So we do a new chapter. So chapter 6, functions. All All right. Maybe. There. I don't know why it starts with this so wide. That's crazy. All right. So actually, right here is a function. How fun is that? They give us one. So before I've just deleted this starter script here because we don't really need it ever. But it's a fun, quick little example here. So where it says def is short for define. Again, we've saved 3 letters. Yay. Good job, Python. So this is defining a function. So you see the def keyword. It means, hey, I want to define a function here. The next thing is the name of your function. Just like our variable names, you can make it up, anything you want, as long as you follow the rules, right? You can't start with a number, you can't have the special character first, or something or other, right? But generally, letters and underscores, they work out pretty well for us. And we do the underscore, the snake casing, right, between every new word here. So this function is called print high. So without actually looking at the rest of the code here, if I shrink it down, what do you think print high does? Yeah, prints high. So that, the name kind of describes what it does here. So we're putting a nice name to what our code is doing. So if you don't actually see the code here, later, if name is main, we'll talk about that later. It says print high, and then in quotes, PyCharm. So what do you think is going to happen? Print high PyCharm, yeah. So name is an argument here, or a parameter. Technically, this is the argument. When you give a function an argument, you're satisfying its parameter. So in the function, it's a parameter. When you call it, you're giving an argument. Most people use them interchangeably, but some people like to argue semantics, so sure. So we've already done other functions before, right? We've done lots of functions, like print is a function, and it takes an argument of what do you want to print, right? So we're calling the print function, and we're saying hi there. So we've used functions up and down. We've used functions out of the math library, right? If we import math, right? We would print math.round, or isn't it round? So we did ceil, short math.ceil of 5 divided by 2, right? This is a function, math.ceil. Ceil is the function, and the argument we gave it is some value. So we've been doing these a lot. So then we can see what it actually does. So you put a colon after, just like with our loops or like our if statement. So anything after this gets tabbed in, and it belongs to this block of code now. And all it's going to do is print hi and whatever it was given here. So whatever you pass as name is just going to spit right back out here. Right? It doesn't do anything interesting with that argument. It doesn't do anything interesting with that parameter. But everywhere else now inside this code, it has something called name. And it will, whatever you gave it will be the name here. So this is lots of fun. So this is the initial function. So we can make our own function, make our own functions to do all sorts of things, right? One of my favorite things to do with functions is to get some sort of valid input, because we do this sort of thing a lot, right? So if we wanted to get some sort of input between a given range, right? So I can define a function. So I want to get value between, or I don't know, in range. And then to tell me if it's within range, I need the low, I don't know what, lowest possible, and I need the highest possible. So I'm going to have to give this function 2 values, the lowest possible and the highest possible. And then what this can do then, it can ask the user, okay, please enter, and this is probably a number, right? How about integer? That makes more sense than value, right? Because we're going to do a range here. So we'll print, enter a number. And if we do this as a formatted string, I can say from the lowest possible, dash, to the highest possible. And then I'll get that value. Right, so then my value, integer, is that right? Integer, that's probably right. Value is an int of an input. Oh, actually I should just put that right here, right? And then I need to print. Put that right in my input. And we have the value, right? But we're going to use one of those validation loops. We're going to say, as long as that value is not good, I have to keep on asking here, right? So I want to keep on going then. Now, I don't really have a good way of setting it to a bad value, so I don't really know what their lowest possible is. I guess I could do that -1 or the highest +1. Or I could just say, while my value, so I want the lowest possible is less than or equal to the value, is less than or equal to the highest possible here. So that is good. So I want all of that as not that. Right? There's one way we could write it. Or we could also write it, if you like the other way, you could say, well, the value is less than the lowest possible, or the value is greater than the highest possible. Right? Either one of those perfectly fine. Whichever way you like to write it here. Both should do the same thing, right? Because it is valid, and then we're taking the opposite of that, or this is invalid low or invalid high. Either way should work for us here. So while it's not valid, maybe then we just tell them invalid, please try again, and then we give them the same prompt. That's probably fine here. Eventually, we should get something that works if the user can read and types in the right thing eventually. Sure, and when we're done, now to give something back, right? The first one just printed something and was done. It was not super interesting. The other functions we've used, so like print just does something and it's done. We don't get anything back. But all the other math functions, like math.ceal or rounding or flooring and doing other values, or like int is actually a function to convert to an integer. Input is a function that gives us something back. So to give that thing back, use the return keyword. So we're going to return the value. Right? So then I can have my, my guess then is equal to a get integer in range. So I call by name, get integer in range. I have to give it the lowest number, 1 to 100. And now PyCharm is being helpful here. I didn't type out lowest possible, and it's not actually there. Notice there's like a different color gray. It's just labeling, this is the name of the argument, the name of the parameter here, so that in line I can see exactly what it is here. This gives me some nice helpful hints here, right? So again, like our number guessing game that we did, right? So we're going to say number of guesses was 1. So we get their guess here, and while guess does not equal, we have to pick a random number, right? So random number. I guess we have to ask for a high and a low. Goodness. We'll just do 1 to 100. So what does not equal? So number 2 guess is random.randint 1 to 100. And I want to import random. Import. It's not the way I want to do it. There we go. Import random. There we go. Well, it's not the number to guess. Then we'll keep on getting another guess here. And then we'll take our number of guesses plus 1. Eventually, they should guess the right number here. And then we can print, congratulations, you got it. In some number of guesses. Right? We haven't done anything different than we did before. Right? Still the exact same program that we had last time. But all we've done now is we've put one small piece of this code into a function. Right? There's a really fun technical term, and I would love for you to hang on to this until your Halloween party, or do you get together for Thanksgiving with other people, especially family. It's the best with family. So I want you to know the term functional decomposition. Taking a big problem and breaking it down, decomposing it smaller and smaller and smaller pieces into smaller functions. Right? That's really the art of programming, is functional decomposition. How do we take a big problem and break it down into small problems? Because I don't know if you've noticed, but small problems are easier to solve. Big problems are a little bit harder, right? So what do they say? How do you eat an elephant? Never heard that before? It's one bite at a time, right? Take a big problem, break it down into smaller and smaller and smaller pieces, right? Oh, it's like a whole train of jokes, right? They're like, how do you put a giraffe in a fridge or something like that? You have to open the fridge, put the giraffe in, close the door. How do you put something else in the fridge? Well, you have to take the giraffe out first, right? And then, okay. It's probably better if someone who's actually funny tells you. But functional decomposition. I know I don't usually offer extra credit, but I am willing to give you an extra point if you can record people's expressions when you just drop that middle of conversation, because they're just going to look at you like you're crazy. They're like, oh man, I was so busy doing the functional decomposition the other day. You're like, what? Nerd. My favorite technical term is functional decomposition. But that really is the hard part of what we do. Like, even before we had functions, we looked at the first project. We said, okay, well, that's a lot of different things to do. How do I do the first piece? right? How do I figure out if the posts are the right distance here? How do I figure out the lengths here, right? Step by step by step, decomposing things. So we can use functions just to put a name to something, right? We didn't write any less code here, right? We actually have like another line of code or 2 extra lines of code because we have some definitions here. But now what it lets me do is this looks a little bit easier to follow here if I ignore the rest of the functions. Like with that starter code, if I just shrink this down, you probably know what this is doing just off the name of it. And if you don't know what it's doing, give it a better name, right? Like with your variable names. If you don't know what number of guesses is, you named it badly, right? Like don't do n guesses, n guesses. That's not helpful for anybody, right? Just spell it out, right? Go back to number of guesses. That's actually useful. Same with our function. So we can put names to what we're doing here, even if we're not reducing the amount of code we're repeating here, right? Now, other times when we have lots of prompts here, so say maybe we wanted to get the highest and the lowest value here. So we'd have to say the lowest possible then should be an int of an input of enter the lowest possible value, and then the highest possible is an int of an input, enter the highest possible value, right? And then I could pass the lowest here instead of 1 to 100. I can pass lowest to highest. Now, these don't have to match outside and inside. Right? It's actually warning me that it's doing that. It's like, hey, this shadows a name from the outer scope. Scope is a fancy thing we'll talk about in a little bit. So you don't have to name them the same. This could just be lowest, right? It could be A. Python doesn't care what you give it to the function. It knows inside the function you've got this value that we can use. Right? So then lowest possible and highest possible. And again, because I copy pasted, lowest and highest possible. All right, so we've got this. Now, getting the int of an input, it's a little bit of typing here. It's not the worst thing in the world. So if we wanted to, we could make a function to do that for us, right? In a single function rather than having to say int of an input. This is not super helpful, but we could, right? So we're going to define a new function. This is get integer input. And then what do I need to tell it then is the prompt. Right? What are you asking for?
The lowest possible.
Yep, so we can use this function for get integer input then. Instead of int of an input, we can get integer input. Right, I got too many parentheses, right? And what this needs to do then is it should get that input, right? So we're going to say, here's the value is an int of an input of the prompt, and I can return the value. Now, you can actually shortcut this, and you can just say return this if you want. Some people like single lines, some people like 2 lines. The problem with this one is you can't really debug very well because you don't really know what the value is right away, versus if you store it, then you'll be able to see it in debugger for what that's worth. Right, 1 line versus 2 lines doesn't really matter. And if you ever go to a place and for some reason they still don't understand how developers work and they measure productivity by lines of code, like, oh look, you wrote 1,000 lines of code this week. Good job, A+. Okay, I can double the amount of code I write really fast. Now I'm writing twice as much code. I'm so effective here. Everybody who actually is a software engineer knows that's a terrible way to measure things. Sometimes you get managers who don't actually know how to do the job. I don't know if you've ever experienced that in the world. Managers who are just clueless. But it happens. It does happen. So, right, whatever you prefer here should work. Right, so now we made a function, and we're using it more than once. We feel good about ourselves. Right? You don't have to use it more than once, but you can. Right? We can do these sorts of things. Other fun functions are getting things in like a certain rate. We said we could validate, hey, you gave me this value or this value or this value, and then it was good. Right? We can do that same sort of thing here. So we're going to get value, valid value, sure. So given the prompt and the list of valid values. So if you tell me, here's the prompt, here's what you want to ask, and here's the list of things that are valid, right? I'm going to have their value, sure, why not, is an input of the prompt. You tell me what you want to ask. Hey, enter your favorite color, right? So maybe we'll say this is valid colors, because for some reason we're only going to have the rainbow colors. I don't know, red, orange. Yeah, did I spell orange wrong? Oh my goodness. Orange, green, blue. I don't know how to spell indigo, so I'm going to skip that one. Is that all right? And then purple. We'll call that good enough, right? I'm not even going to try. Right? Okay, so if this is a list of valid colors, I say, hey, enter a color, or enter your favorite color, whatever we want to do here, but I only really want one of these back. Right? That'll be my list of valid values. So then I'll get, I don't know, favorite color is my get valid value. The prompt will be enter your favorite color. And then the list of valid values, you just comma separate these things. Your list of valid values then will be the valid colors. Okay? So then I'm going to pass that in to my function here. It's warning me now it hasn't returned anything. So PyCharm is like, oh, you wrote a function, you didn't hit return, and you're trying to store a value here. You're trying to save something that came back, but if without that return keyword, nothing's coming back. It's just a little warning here. So we can say, while my value is not in the list of valid values, not in list of valid values, well, I don't know, we'll tell them that's invalid, so print invalid choice. And maybe we tell them what the list is here, right? I don't know. Maybe that'll be helpful here. So the list of valid values, like please pick from, or something. And then we do it again. We get their input. Eventually, they'll give me something that is in that list, and my loop will stop, right? And then I can return that value. So this one's pretty handy here, because my prompt might be different every time, and my list of valid values might be different every time. Like to play rock, paper, scissors, lizard, Spock, the prompt is, do you want to throw rock, paper, scissors, lizard, or Spock? The list of valid values is rock, paper, scissors, lizard, or Spock. Or maybe in your case it was 1, 2, 3, 4, 5. And you could pick a 1, you could pick a 2, you could pick a 3, you could pick a 4, you could pick 5. Sure, that's fine too. Right, whatever we want to define this as, we've got that choice here to us. So we now have some flexibility when we're writing our code to not have to do the same thing over and over again. Right, we can reuse some code. It's a bit of a pipe dream, but we use the math library, we use the random library. There's all sorts of cool libraries out there. One of those big ideas is that we'll eventually have a library of functions of our own that are just so good and amazing that everyone else will want to use them. Now, I want you to set the bar appropriately high, which is really low, because this is your first year coding. You're not going to write any really amazing library functions that anyone else cares about. That's okay. You'll get there eventually, right? Give it some time. That's why you're in school, hopefully, to learn some things, to go out in the industry and be good at stuff, or go do some research if you want to continue on, because education's cool, right? I got to do the Adam Sandler voice for that, but I'm terrible at voices, right? Then maybe we'll have some cool library functions that people think are cool and people want to use. So you can get there, but baby steps, little step at a time as we go. So we can reuse this get valid value for every one of your programs, because almost everything we're going to do is ask the user to do something here, and there might be some sort of range of values, whether or not it's a high or a low, or here's the range of values that are valid. We're going to do these sorts of things over and over and over again, because our bag of tricks is kind of small, right? So cool. These are fun little functions we can use and have in our pocket. Saves us a little bit of time. Okay. I should probably run this and make sure it works. I haven't ran yet. That's pretty bad. You're supposed to write some code and run it, write some code and run it. I got too excited here. So let's give it a try. So enter your favorite color. So if you enter sky blue, it says, oh, that's invalid. And I'm sad because sky blue is my favorite color. I guess I get regular blue. Still invalid, right? Oh, Python's case sensitive. Uh-oh, and this one's capital B blue. Okay, sure. Capital B blue. All right, that worked. So now I was able to get out of that loop, return the value. I didn't do anything with it now, but I got a value back. So lowest possible value, we did 1 to 100. Right, and then enter number 1 to 100. 150. 0. Negative 50. How about regular 50? Why is it asking me twice? Let's see, what did we do wrong here? Oh, because we didn't guess. So now we have to guess the number. That's right. The first prompt was just to get a number. Now we're guessing the number. I didn't tell you too high or too low. This might take a while. I probably should add in the too high or too low, right? Okay, so if we have to do this first, right? So if guess is less than the number to guess, print too low, else print too high, right? Because if it wasn't too low, it must have been too high because it wasn't equal to, you never got it, and then we'll get a new guess, and then we'll check it again. All right, blue, capital B, 1 to 100, 50, too low. Okay, there we go, 75, too high. Now we can start going here, 62, too high, 57, too low, 59, too low, 60, 61, 62, 63, 64, 65, didn't I guess 65? 66, 67, 68, 69, 70. I think I broke something here.
Something's not right.
What is not right here? 70, 71, 72, 73. This seems wrong. What did we do wrong here? Guess. How does that still tell me it's too low? I should have run this in debug mode. Wild guess is not the number to guess. Numbers less the number to guess. What did I do? It was giving me different values before, right? Didn't I get a too high and a too low? I got a too high and a too low at 75. Huh. I'm real confused now.
Maybe it's a random number every single time you
It
do the loop.
shouldn't have, because it happens before my loop here. Get integer and range. Lowest and highest. We never did invalid, so it should just returned. Wow, what happened? I'm gonna run in debug mode and see if it happens again, because that was crazy. That should not have happened. 1 to 100. 50. All right, here we go. The number to guess is, let's step over once. Number to guess is 43. Right, so 50 should be not too low. We're gonna print too high, get a new value. All right, enter number. That was too high, so if we do 25, add number to guess. Guess is not the number. It's less than, it's too low. Get a guess again. All right, should we try, what was the, I forgot already what the number was. 43? What's the number to guess? 45. Oh, I did it wrong, I'm sorry. 43 was too low, 45. What? What? I figured it out. I was increasing the number to guess, not number of guesses. This is number of guesses. This is number to guess. I kept changing the number by 1 every time. Yeah, that would make that wrong. Okay, number of guesses. And that's why I told me it took me 1 guess. Number of guesses. Okay, we found, I totally did it on purpose to show you how errors happen in your code. None of you picked up on that either. No, I don't feel as bad. I used the wrong value here. Okay, just I'll make sure that works one more time. 1 to 100, 50, 75, 67, too low, 70, 72, 71, 6 guesses. Looked like it worked that time. And this is why we run our code, right? It's important. All right, feeling a little better now. Let's go back to functions. Let's see, wrong book here. Don't want that one. All right, user-defined functions. This is us, we're defining functions. So we could make one to convert Celsius to Fahrenheit. Woo, super exciting. The function definition, the function call, so when we define the function, here's your function. And functions don't have to have arguments. They're just kind of boring if they don't, right? So you can define print Happy Monday with no arguments here, just empty set of parentheses, and it just prints Happy Monday. And because we're super obnoxious, let's do it like 3 times in a row, right? And let's try that. So maybe we'll print Happy Monday at the top. So it will run and do that thing, right? Now, another fun thing with debugging here, I should show you this as well. If you step over, it doesn't go into the function code. It steps over that function, right? So step over, it just does the function and then never see it happen here. But like my get valid value, if I want to go into that function and see the code that's happening, I can use the step into button. So now we start using some of the different buttons instead of step over. So if I step into, now we see, oh, hey, I jumped to this line here. Right? It just says, hey, go to wherever this was. So now I'm at line 23. And how Python tracks this behind the scenes, we have this thing called a stack. This is the call stack. So we were at line 31. Now we're at line 23. When this part is done, it'll come back to line 31 and just keep on going here. So it'll track this here for us. So this is the call stack. So when things crash, like if you give it invalid values, it'll actually print out that call stack for you as well, which is really cool. So I'll show you that. Let's do step, and so we'll prompt. So if I give it, oh, I can't do it with this one here. We have to, one of the integer ones will crash here. So we'll just give it blue, and step, step, step. All right, so now this one now for an integer input, if I give it like 10, that was weird. No, 10. It crashes. Right? So what I'm getting here is the call stack. So this big ugly thing here is saying, hey, at line 19 in get integer input. This is where it crashed, but just before that, you were at line 33 of getting the integer input from the lowest possible value. Right, so you can see here's where we were, where it crashed, here's how we got there from this line here. Right? So as our programs get bigger and bigger and bigger, we have more and more functions, you can track that down. Sorry, my phone should be quiet here. And see where it got to it, which is really cool in that call stack. Yeah, so functions that, this one doesn't return anything. You don't have to return values. You don't even have to take arguments. But most of the time, the useful, interesting functions take arguments, and they might return something, they might not, depending on what you're working on here. So our functions, those are parameters and arguments. Yep, we talked about those. Those are fun. You can have hierarchical function calls or nested function calls, right? Int of an input is a function inside, like we've given the result of this to another function. We've done this a lot. We can pass those in. Cool. Print functions. Right, you can give it some values. That one's pretty easy. You can call it multiple times, print, print, print. Yeah, that's fine. Now, this dynamic typing thing in Python is a little bit weird. So because Python is dynamically typed, unlike other languages, if you programmed in something like Java or C# or C++ before, you have to tell the compiler, the language, what type we're using. Hey, if I want to use an integer, I have to tell it it's an integer. Python says, oh, you assigned me a 1, I must be an integer. Because Python is dynamically typed. It says, oh, it looks like a 1, it looks like an integer, you must be an integer. It lets us do some weird things here. So when I want to get integer input here, right, and I give it a prompt, nothing really says this prompt has to be a string. Okay? You don't have to give it a string here. You can do some weird stuff here. So their fun example here is define add two things. Right, and we'll have thing 1 and thing 2. And we'll have a fun day and a rainy day, right, with the cat in the hat. So we're just going to return thing 1 plus thing 2. Okay, so we can add two things together. Now, you can add a lot of stuff together in Python, right? So I'm going to print add two things given thing 1 and thing 2. I'm also going to print add two things given, I don't know what, 10 and 12? Too many parentheses here. No, that was the right number of parentheses. Right? Both of these will work. Thing 1, thing 2, you can take two strings, you can add them together. Python says sure. You can take two integers, you can add them together. Python says sure. But what you can't do is add two things given thing 1 and 2. Right? Now we're going to confuse Python. It says can only concatenate string, not int to string. Right? It crashed at thing 1 plus thing 2 at line, that's a little too large, line 4. It got there from here when I tried to call add two things given thing 1 and thing 2 at line 36. So sometimes knowing where it crashed is not as helpful as knowing what you gave it to why it crashed here. That's why these stack traces are really nice here. Explain with AI. That's a new button. That's fancy. It's going to tell me what I did wrong here. JetBrains AI assistant. Oh, only if it meets corporate policies. Oh, activate only if it meets corporate policies. That's fun. I didn't even think this was on for, it's a free 7-day trial. They want you to pay for it, of course. Yeah. You're not going to get this for free with the community version, which is good. I love AI things, but again, too much magic and not enough of you knowing what the magic is doing is not going to be helpful, right? We got to use it very specifically for things. Like tons of developers are actually using AI to make them faster, but they generally know what it's doing, or they should know what it's doing. I can't, I guess, say that concretely that they all know what it's doing, but they should. What is the survey here? Like number, percentage, developers using AI tools. It was like in the high 70s last time. 90% now. Wow. US-based developers. Okay. 92%. This might just be based on who they surveyed. Yeah, Microsoft GitHub. Using some sort of AI tool in their workflow. This is cool. Yeah, I've talked to some of my buddies, the place I used to work. They use them all the time too, to automate the boring stuff. Definitely. All right, I got distracted. So someday we'll get there. We'll start using those tools, but really for now it's just not going to work very well for you because it's going to do all sorts of magic and suggest things. And if you don't know what it's doing, it's really dangerous, right? I mean, these are silly little examples here. It's not going to do anything bad. But eventually you'll write software that is momentous and really important to society and does really cool things. And it screwing up would be bad, right? So you have to build up that expertise to know what you're doing. All right, so functions. So this is dynamic typing. It's super cool. So another term for it is duck typing. If it looks like a duck and sounds like a duck and walks like a duck, it's probably a duck, right? If it looks like an integer, sounds like an integer, I don't know. That's how Python figures what out things should be here. So it's not static typing like other languages, like C++, C, and Java, those sorts of things. They use static typing. Now the other weird thing that you can do though, which is, if you want to, you can say number of guesses equals 10. Python warns us, hey, we're changing the value here, we never used it. But you can go from an integer to a string, and Python says, sure, that makes sense. Go for it. So if you're getting input, it can change things. Now, usually it's always strings, but we can go do conversions. But anything you want to assign to Python, it's like, sure, I'll go for it here. So just got to be a little careful here when we do that dynamic typing. Cool. So with our we could like turn this into a function too, right? Let's do that. So I'm a little bit lazy, so I'm going to go to refactor, and I want to say extract method. So if there's something you want to turn into a method or a function, so methods and functions are mostly interchangeable. If you really want to argue details, you can, but we'll call them all the same. I'm going to say extract method, and we'll call this print too high or too low. Sure. We're going to print too high or too low. Now the problem is it needs to know some values though, right? It needs the guess and it needs the number to guess here. So I have to go find where it had that function for me. Where did it put it? Print too high or too low. Where did it go? Oh, right here. Right. So it needs these values here. I copy this in here. So if you give it the guess and the number to guess, it'll print too high or too low. Right. So now I have a one line here for my loop, right? This is printing too high or too low. It's getting the guess. Change my number of guesses. Right. Nice, pretty little loop here. So like 4 lines for a little number guessing game here, which is fun. And notice I put the function above. You can put it down low, but then Python says, oh, unresolved reference, print too high or too low. Python has to have read it at the top of the file somewhere before you use it. Python is rather particular about that. Other languages are a little bit better, but Python's cranky. So generally we put all of our functions at the top here. That'll make everything happy, right? And then we can use our function here. All right, so number of guesses, we get our guess, get our random number. Great, so we got our number guessing game. What were we doing with that? So to turn something into a function, right? If you don't want to have to cut and paste yourself, you can use that extract. Sometimes it picks up your argument, sometimes it doesn't. Depends on what. It's not always the smartest. Sometimes it's helpful. All right, so we've got our functions, reasons for defining functions, right? Readability. Like, put a nice name to what you're doing here, right? One nice thing is like, if you just look at the program here, it's pretty short and sweet now. I don't have to see the rest of it, and I just see the name here, print too high or too low, get an integer in range. I can sort of get a feel for what's happening here just by the names. And this is why some of us live in that school of thought that comments are stupid. Because if you have to put a comment in telling me what your code's doing, you didn't give it a good name. Like, print too high or too low. You probably know what this does. If you have to put a comment in and say, hey, this function prints too high or prints too low, you've wasted everybody's time. Not all your profs are going to be like that, right? So if they require you to put comments in, just smile and nod, right? You can think they're an idiot. It's okay. I do all the time. Don't say that out loud. They get real offended, okay? Don't try it. I can get away with it sometimes. Your chances are lower, right? But it's okay. Some people love their comments. Sure. Academia is a really weird place where a lot of people on the tenure track who are research faculty, who are like super smart and know lots of things, never worked a day in their life in industry. They don't actually know what industry does, but they just know their research, which is great. We love research and we use that in industry all the time. But they don't know what it's like out there. So some of their views on things are just way out there. But that's okay. All right, so our functions. So readability, love readability. Modular development, right? Doing this thing into small pieces, breaking things down. My functional decomposition. I want to divide my program into separate pieces. Here, break it down. It's easier to test small things at a time here. Avoid redundant code, right? If you have the same code in your program twice, you should feel bad about yourself. It's a pretty good rule of thumb, right? Those are some nice reasons here. Writing our own mathematical functions, right? Converting US to C, height US to cm. Why don't they say feet? Why does it say US? Why is this US? I mean, yes, we're the only idiot country who uses this measurement system, but it's feet. Like, let's be specific. Okay, so feet and inches, then we can convert to centimeters. Sure. Temperature conversions, right? C to F. Just use something better, right? Spell it out. It's not hard. Calling functions in expressions. Right? You can do your function calls in line. If you want. We've done this stuff before. That one's not super new. We imported the math function. Now, one other fun thing is you can put functions inside of functions if you want. Right? So we're going to define call me first. Given, I don't know, we'll say name, and then we'll print hi name. And then we're going to say call me second, given name. Now, I have to have that, if a function calls a function, the function it's calling has to be above here, so this is call me second. Given a name, print hi, I'm second, or hi name, I'm second. And you can go as far as you want here, so call me third, given a name, we can print hi there, name, third here. So this function, we'll call this function. This function, we'll call this function. This function will do something, right? We can. So you can chain these things together to have functions that call functions that call functions that call functions, as many as you want, right? There's a theoretical limit at some point here. Oh, I gotta give it name, that's right. It's complaining here. Let's go back and call me first. Let's do call me first with Eric. And we get, hi Eric, I'm second. Hi there, Eric, third here. Right? And if we put a breakpoint in and want to watch it in debug mode, we can step into each of those function calls. and it's just going to keep adding to this call stack here, right? Every time we call a function, it gets added to the call stack because Python says, okay, now I'm here at line 4. When I'm done, here's where I go back to. When I'm done with this one, here's where I go back to. When I'm done with this one, here's where I go back to, right? Now, what you can do, but I don't recommend it here, is you can call first here, give a name. And now we get maximum recursion depth exceeded. So we just looped infinitely here with functions. First, second, third, first, second, third, first, second, third, first, second, third. Because the first said call second said call third said call first said call second, right? So eventually it'll crash here. Right? You can't call this without limit here, because that call stack that Python has can only get so big before it just pukes on you. It says, nope, that's no good here. It's the maximum depth. So don't make infinite loops with functions like that. Okay, that's your pro tip. Okay, the functions can call functions. Another fun thing you can do is you can start writing function stubs. So when you write a program here, you can just stub out your functions, like steps to calories, and just have it do nothing. Or like, fix me, I'm not done yet, and just do something. You can raise errors. We haven't really got to exceptions yet. I wouldn't worry about that. We'll talk more about that later. But if you're like, hey, here's a big problem, it will be this function, and then this function, and then this function, and then this function. You don't have to write them all at once. You can define the function and come back to it later, right? But Python doesn't let you leave it empty. It starts complaining here. So if I'm going to write a function, finish this later, that takes X, Y, and Z, because who knows what X, Y, and Z are. Now Python's mad at me, right? I can't even run my program. Indentation error, expected an indented block after function definition on line 4. That's actually a useful error. That's telling me pretty clearly what's happening. You named a function, but you didn't give it anything inside of its block here, right? Okay, so we have to have something in here. So now maybe we print the fix me or something. So now we have a stub of a function, at least, right? And I can come back and fix it later. But now I can define a bunch of functions with my program and come back and fix them after. So stubs are really useful for doing those. You can make functions with code. Who knew, right? All the stuff we used to do, you can put inside of a function. It's not limited to just 3 lines or anything, right? You can have a gazillion amount of code, bunch of code inside of that if you want. Functions, more functions, more functions, more functions, lots of functions. Doing good. Functions are objects are weird. We're going to save that one for later because that gets a little crazy. Common errors, scope we can save for later. Yeah, I think we can save most of this for Wednesday, so we've got some stuff to talk about. Lots of fun things with functions. Does that sound okay if we save some of this for later? Okay. We got lab at 2. Unfortunately, I got double booked with a meeting I can't get out of, so I need like half an hour till I can get there. So I'll post the lab. We can get started on it. I'll be there about 2:30 or so to help get working on that. And I'll bring coffee for sure. I'm hoping they put the free coffee back in, although Keurig coffee is just not, it's hot and black, which is okay, but it's not the same as Starbucks coffee. So we'll do that. So I'll post the lab for you in just a minute. We're going to practice writing some functions, just do some silly things with functions, and we can go from there, okay? All right, awesome. So I'll see you guys about 2:30 over in lab.